Hello everybody, it's Mr. Matthew Does Coding, and today I'm going to be explaining every single keyword in Roblox Studio. Now, what I mean by that is I mean that we're going to talk about all the words that appear by default in red, like local and function and break and while, those kind of words. We're going to be covering what every single one of them does in depth, because I did make a video a while back on this subject, but I wanted to make it as concise as possible, kind of like those videos where it's like everything you need to know in 2 minutes kind of things. But were a couple people in the comments that said that they would like to have a more in-depth, slowed down breakdown of all of the different keywords. So, as per your guys' request, I'm going to go over all of those in this video. Now, we're going to be using this part right here, Jerry, as our kind of example for how we can use all of these different keywords in conjunction with Jerry. Now, the first keyword we're going to go over is the building block of basically any piece of code, which is local. Now, local is used to define a variable, and a variable is just a name that you can assign an object inside of your game. It doesn't even have to be a physical object. It can even be like true or false. You can assign it to a number. You can assign it to a string. You can assign it to a char. You can assign it to really anything. It just gives a name to something specific so that you can use it later. So we're going to reference Jerry right here at the top. We're going to write local Jerry equals game.workspace.jerry. And that's really all you have to do. So instead of having to reference game.workspace.jerry every single time we want to use it, all we have to do is just type in Jerry. It's really concise, and it helps with the readability of code, and it's just the most amazing thing in coding. Now, we can't really do much with Jerry right now because we just have him as a variable. So let's actually check some things about Jerry. So for that, we're going to use if statements. So this comes with two keywords, if and then. And when you hit enter on this, you'll get an end. End is not really something that I need to cover for much time. It really just marks the end of a block of code, like an if statement or loops that we'll get into in a little bit. Now, what you need to do with an if statement is you need to put a condition in the middle of it to check to see if it's true or false. If it's true, then the code inside of it will run. If it's not, then it doesn't run the code. So let's check something about Jerry real quick. Let's check Jerry.anchored. So if Jerry is anchored, then this code will run. If he's not anchored, then the code will not run. So let's do this. We'll do Jerry.color equals color3.new, and then we'll just assign him to a nice bright red instead of this white. So if he is anchored, then it'll change it. If he's not anchored, then it won't change it. So we'll run it and we'll see what happens. Nothing happened here, because if we look at his properties here, Jerry is not anchored at all. So what can we do about that? If Jerry is not anchored, what if we want him to be a different color? And that's where else comes in. You can replace your end right now with else, and then when you hit enter, it'll create another end. So all else does is say, run this chunk of code here if this statement does not pass, or whichever statement above it does not pass. So if Jerry is not anchored, which he isn't, then instead we'll make his color like a, I don't know, bright purple. And now if we run it, we'll see that Jerry has turned a bright purple because he is not anchored. But if I do anchor him and then run it, now he's a bright red. Simple as that. Now, there's extra things that you can add to your if statements to kind of spice them up a bit in case you do need that. And I'll talk about all of these together. There's and, or, and not. All of these can be put into here to basically add to your conditional statement. So if you want to check for two things to be true about Jerry, then you can put an and. So if he's anchored and his name is Jerry, then this will run. I forgot to mention this, but whenever you're writing conditional statements that have an equal sign involved in it, like this is, if this is equal to this kind of thing, you need to put a double equals, because a regular equal sign is an assignment operator. That's the fancy term for it. It's assigning something to something else. But a double equals is like a check. That's why you need to put the double equals there instead of a regular equal sign. But yeah, that's basically all you need for the and. And then I'm going to change this to an else if. That's another one. If you want to count that as a separate keyword, it kind of is and it kind of isn't, because it's a fusion of two different keywords. But whatever. If you want to have another if statement here, then you can put else if Jerry.anchored equals false, or Jerry.name equals I am not Jerry. And I forgot to put the double equals. And then we put then. So obviously we know that Jerry is not named I am not Jerry. So this part is not going to pass the conditional statement. But this part is going to pass. Therefore, this code will run, because all or does is make sure that at least one of the statements is true. So if we run this right now and turn off the anchored property, then what we get still is an error message, because I forgot to take out the ones at the bottom. Oops. Right there. We get purple, because although Jerry is not named this, his anchored property is false. So this will still run. But if we do anchor him, we'll see that he'll turn a bright red, because both of these statements had to pass. He's anchored and his name is Jerry. Now, where things get a little bit interesting is when we bring not into the mix. Now, what not does is it essentially checks to see if something is false. So instead of putting Jerry.anchored equals false, we can put not Jerry.anchored. It kind of simplifies it. But if we wanted to have something with the double equals in it, like we can't avoid not having a double equals here. What we need to do is we need to encase this statement in parentheses to cancel out like some weird kind of things that go on with the program. Because if I bring this out of the parentheses, then it starts to get mad at me. Now there is a different way to use not in these contexts, which is to use the not equals operator, which looks like this. Now you can do this, but the reason why I didn't cover this first was because the video is about keywords and not is a keyword. So this is just a different way of doing it. So now that we've gone over all the if statement stuff, let's talk about a completely different concept now. Let's talk about functions. Now, a function is a piece of code, or a block of code, I should say, that you can run at a different point in time in the script. Now, the way that you write a function is by saying local function, because the function has to be assigned a variable name to be called later. And I'm just going to call it change Jerry, because we're going to change some properties about Jerry. And then you hit enter, and there you go. You've created your function. Now, if you want to call this function in a different part of your script, all you have to do is type change Jerry with the parentheses. And there you go. And it'll even highlight yellow if you're using the default color scheme for the text editor. But yeah, it's pretty simple to use, really. And we'll put some stuff here into the function so that you can see it actually work in action. We're going to set Jerry's size to be vector3.new 10, 10, 10. And then we're going to set Jerry.anchored to true. And finally, we will change his material to be enum.material.neon. There you go. And now I can call change Jerry here in the script. And boom. Now he's a big old cube. He's anchored. You can see if I lift him up here. Yeah, he's anchored and he's neon. And the red came from up here, by the way, in case you're wondering. Now this might seem a little bit weird. Like, why can't I just do this? Why do I have to call a function for that? Well, there's multiple scenarios where you might want to call the same chunk of code more than once. And it also helps with readability, because if you just have this block of code here, that might be a little bit weird to come back to and say, what the heck was I writing when I made this code? And you don't want to have to do that. So if you assign it a name and then you call it by that name, it's easier to identify what that block of code was when you wrote it at like 3 o'clock in the morning with like no energy left in you. Because trust me, I've been in that situation before where I'll wake up and then I'll have no clue what I just coded. And, you know, there were some points where I didn't assign a variable or a function name to something, and then I had to go back and decipher what I wrote that night, like an ancient Egyptian hieroglyphics or something. But that's basically a function. Now, we can add a little bit to our function by adding in a keyword called return. Now, what return does is it does what the name implies. It gives something back to whatever called that function. So if we wanted to return, let's just say we'll return a number. That number is going to be 15. Now, when we call this function, this line is going to receive back the number 15. So we can utilize that return value by making this into a variable. So, you know, it all comes full circle. We'll say change Jerry return equals change Jerry. So what this is going to do is it's going to call this function, and then it's going to assign this variable to whatever the function returns. And if it doesn't return anything, then this by default is going to be nil, which just means nothing. Now, we can prove this by printing this, right? There you go. See right there, 15. And we can even do like math operations with it if we wanted to. It's pretty cool. There's a lot of more complicated pieces of code that you can use that definitely utilize return statements. Like in the game that I'm making, The Valley, there's a lot of functions that the client calls from the server, like to receive inventory data. So I use the return keyword inside of those functions so that the client can get returned the data that it needs in order to like display all the slots in the inventory. It's really cool stuff, really. I know this is a very like elementary example, but there are a lot more practical uses for this. Now let's move on from functions and let's talk about loops. Now there's 3 different types of loops. One is a while loop, another is a for loop, and the other is a repeat until loop. The repeat until loop is rarely used, and I like to call it the weird redneck cousin of the while loop. And you'll see what I mean in a little bit because they basically do the same thing, but they just look different. It's kind of weird. But all these do is run the code inside of them over and over and over again until something happens. Like with this while loop, you put a conditional statement, kind of like the if statements up here. And while this condition is true, do this code. So it kind of spells out itself. So while Jerry dot name equals Jerry, do. And you need a double equals here, just like the regular conditional statements. And then it's just going to, I don't know, let's do this. Let's have some fun. Jerry.size equals Jerry.size plus vector3 dot new 1, 1, 1. And then at the end of every single while loop, you must put a wait. It doesn't have to be for any specific amount of time, but it just needs to be a wait. Because if you don't put this at the end, and you end up with an infinite loop, which is what this does because Jerry's name never changes, then what ends up happening is your Roblox Studio crashes because it ends up trying to process this command that it's been given hundreds of thousands of times per millisecond. So it overloads your system and then your Roblox Studio crashes, or the script times out and it says, I'm done, I'm not going to run anything anymore. So please, make sure that you put a wait at the end of this. I am going to put a specified amount of time so that we can see Jerry grow. I'm going to run it, and you'll see every half a second he grows by 1. That's all this loop is doing. It's pretty cool. Now, if we wanted this loop to stop at some point, we could put maybe something to do with the size value in here. So while Jerry.size, let's check the x value because all the values in this example are the exact same. We'll put Jerry.size.x is less than 20. We'll go with that. Do. So it's going to run until Jerry's size is greater than 20. You see it stopped. And if we look at its size property, it should be really close to 20. Yeah, there you go. It actually stopped exactly at 20. So that's how while loops work. Now, if you had an infinite loop, you might want it to stop at some point, maybe because of a condition that's checked inside of the loop. And that can be achieved with break. By the way, what I just did here is create an infinite loop. While true, do. True always equals true. So this is always going to run. Now, what break does is it breaks the loop. It stops it from continuing. And usually, breaks are put inside of if statements. Like, if we can basically translate what we just put up at the top into here. If Jerry.size.x is less than 20, then, or we should actually put greater than, because if it's reached that point, then it needs to stop. So there you go. Now, it's going to basically do the exact same thing as before, except now we're going to check for it inside of the loop. And it actually went over by 1 this time. So that is a little bit of a difference that you can sometimes see in the way that you do these things. But breaks are very useful if you want to have like a value updated. inside of your loop, and then you want to check to see if that value has met a condition, and then break it if it has. Now, let's go on to the next kind of loop, and this is called a for loop. Now, bear with me here, this is going to look scary. I'm going to write out a for loop real quick. For I comma v in pairs do end. Alright, let me explain now what this whole scary thing is. What a for loop does is it will cycle through every single value inside of a table. Now, you'll give that table to this for loop with this pairs part. So inside of this parentheses, you'll end up giving it a table value. And that can even be achieved with like get children on some parts. Like you might have like replicated storage right here, colon get children, and then it'll give you a table with all these remote events that I have from previous tutorials in it. Now I'm gonna write out a table at the top right here, not any like existing table inside of the Explorer right now, but I'll just write local table equals curly brackets, because that's how you define a table, and I'm just going to put a ton of things inside of here. I'm going to put apple equals 12, orange equals 9, wood equals 15, and then chicken nuggets equals 99. Something like that. You can imagine this might be like a player's inventory inside of a game that you're making. Now, we can give this for loop the table. And now it's going to cycle through every single value inside of here. Now, that's all fine and dandy, but what the heck does I and V mean? I and V mean index and variable. So this first part right here, the apple, the orange, the wood, these names are the index in the table. So if we printed I, it would give us all of these. And then if we printed V, which is the variable assigned to those indexes, we would get all of these numbers right here. And you don't have to put I and V. I can swap this out for any letter combination I wanted. I can even put like names. I can put Matt and Steve if I really wanted to. But the common convention is I and V because it stands for index and variable. It's just like simple vocabulary that you can use. Now, let's just print I and V so you can see what I'm talking about with the index and variable thing. This is going to run first, and then we're going to get the for loop. See right there, this part gave us the index first, and then the variable, which is exactly what we told it to. And this is really useful when you want to like try and find something inside of a table. Like I use it a lot for inventory stuff when I'm trying to find like maybe if the player has the 16 wood planks that they need to craft like a door, it will loop through the player's inventory table and it'll check to see if the index name is like wood, and then if its variable is greater than or equal to 16. Something like that is a very useful example of how for loops can be used, but this is just, you know, simple little thing that you can do. Alright, one more keyword to do with for loops has to be mentioned, and that is continue. Now, continue seems kind of strange at first, but it's pretty useful for sometimes wanting to skip over a certain variable or only wanting a specific set of variables when you're going through a table. So let's say that we wanted to print out everything except for wood. So we can put right here an if statement. If I equals would, then continue. Now what I've just done is tell the game, if it's would, then go back to the top and go on to the next set of values. So it'll go through apple, orange, and then when it gets to wood, it's going to hit the continue part, which is going to skip over all the code underneath it and then move on to chicken nuggets. So let's hit continue. This is going to grow, and then we'll see everything was printed except for wood, because that's exactly what continue does. It helps to skip over values by skipping the code that's always underneath it. Now, the last thing that I'll go over is a really strange loop. It's called the repeat until loop. Now, this basically serves the exact same function as a while loop, except it's just written differently. So it's repeat this code inside of here until this value is true. Now, we can write an infinite loop here with repeat until false, because false is never going to equal true. Therefore, we get an infinite loop here. And I can just do like print A, and then I'll wait a little bit of time so that it doesn't, crash the computer. And I'm gonna get rid of this while loop here so that we don't have to watch it grow. And then you'll see it's just continuously pumps out A, because that's how you create an infinite loop. This one's pretty weird. I don't ever really see this one used very much, but I just wanted to throw it out there because they are keywords in Lua, and I did need to go over them because I said I would go over every single one of them. But if you prefer this kind of loop, then by all means use it. Thank you so much for watching this video. Please subscribe if you liked it, and I'll see you in the next one. Peace.